In this brief video, you will see a teaching experiment designed to illustrate for high school or university students the fundamentals of using wind to generate electric power. This experiment is produced by Engineering Experiments, LLC. First, let me identify the major components using a laser pointer. The wind is produced by a four-bladed fan, 15 inches in diameter, driven by a 1/4 horsepower variable speed DC motor. The motor speed is controlled by a Bodine speed controller. The speed is manually selectable from 0 to 1600 RPM. The high velocity air flows to a 16-inch diameter four-bladed fan mounted on a Bodine turbine generator. The turbine rests on a ball bearing pivot with a lever arm from the pivot pressing on a load cell. The DC generator is connected to a selectable load resistance of 0, 50, 100, 150, and 200 ohms. For safe operation by students, the fan and turbine are mounted inside a perforated metal shield shown later in this video. Now let me discuss the instrumentation, which is an essential part of the experiment and enables the students to collect data for later analysis. First, a rotary switch allows the load resistance to be selected. Then the speed controller is used to set the desired fan speed. The voltage and current produced by the turbine generator are displayed on two omega panel meters, one for volts, one for amps. The product, of course, of volts times amps is the power generated. Two omega rate meters measure the RPM of the fan and the turbine. The rate meters are connected to optical sensors, which are mounted on the auxiliary shafts of the Bodine motors. The wind velocity running the turbine is measured by an omega vane sensor connected to a panel meter, rate meter, which has highly visible LED display. This makes the experiment suitable for remote operation over the web using a web camera. The velocity of the air leaving the turbine is measured by a similarly modified vane sensor. The sensors can measure wind speeds up to about 20 meters per second, corresponding to 45 miles per hour. Finally, the load cell reading in newtons is displayed on a panel meter at the bottom of the instrument panel. In summary, the students can set the load resistance and the fan speed, and then measure the turbine RPM, turbine voltage and current, turbine inlet and outlet wind speeds, and the force on the turbine. Now let me demonstrate and discuss the operation of this wind power experiment. You see the apparatus running with a fan speed of 1400 RPM and a generator load of 50 ohms. Note that the fan blades are not clearly visible since they are moving at relatively high speed, while the turbine blades move much more slowly. We see that the voltage is 11.12 volts with the current is 0.29 ohms. The power generated is therefore close to 3 watts. For a given fan speed, the turbine speed is lowest at a load resistance of 0, where all the power is dissipated in the windings of the generator. It is evident that velocities V1 and V2 are different. Note that V1, the upstream velocity, is much greater than V2, the downstream velocity. This means that some of the kinetic energy in the entering air is lost to shaft work and other dissipative processes. Note also that the velocities V1 and V2 are somewhat noisy, probably due to the fact that the fan and turbine have only 4 blades, so that the flow reaching these sensors is oscillatory and turbulent. We see also that the force in the turbine is 2.73 newtons. This force varies as the square of V1, while the entering kinetic energy varies as the cube of velocity. Thus, small increases in wind velocity produce large increases in power generated. From V1 and V2 we can find the downstream flow area and then the entering and leaving kinetic energy, and compare this difference to the product of the voltage and the current to find the efficiency. It is expected that the efficiency is a strong function of turbine load resistance with a maximum at some intermediate load. In this final short section of the video, you see the wind power experiment running at about 1600 RPM, the maximum fan RPM. Volts are about 19, amps about 0.46, fan speed 1584, turbine speed 475, wind velocity entering 16.8, wind velocity leaving the turbine 6.3, and finally the force on the turbine 3.81 newtons. The main thing to notice here is the safety screen, which prevents the operator student from touching the rotating blades.